Hello students, welcome to Educate. In the last video, we have discussed till standard electrode potential. In this video, we will discuss about trends in stability of higher oxidation states. So let's see, among this one, we will firstly discuss about the stability in halide and then after in oxide. About this one, in the stability of higher oxidation states. So the transition metals will show the higher oxidation state with the elements which are highly electronegative. So you know already the halogen groups, the halogens, that means group symmetry elements, are highly electronegative, and oxygen is the second most electronegative element. Of the halogen groups, the fluorine is the most electronegative element, and then after oxygen is the second most electronegative element. The electronegativity of other halogens are also very high. So let's see about this one here. What's the transition elements will show the higher oxidation states with halides as well as with oxygen. So let's see firstly how the transition metals will show the higher oxidation states with halogens. Let's see about the beginning from titanium. Scandium, you know already, scandium oxidation state is +3. So that will show only one oxidation state, that's ScX3. Only one halides it will form, scandium, but then after it starts from titanium and this one. So titanium, when you consider about the titanium show the oxidation state till +4. Vanadium shows till +5, but vanadium shows +4 oxidation state only with +4 oxidation state only +4 oxidation state with other halogens also. That means vanadium shows +5 oxidation state with the halogen only in case of fluoride. That means VF5 is stable, but VCl5 that will be unstable. VBr5 that will not exist, or Vi5 that will not exist. So vanadium shows the +5 oxidation state only with fluorine. Same as, and why with fluorine only? Because the bond enthalpy of VF bond that will be high, while the bond enthalpy with other halogens will be less. So vanadium shows the +5 oxidation state only with fluorine. Okay, among halogens, the vanadium shows +5 oxidation state only with fluorine. Okay, and no any other elements. Okay, with here bromine, it shows the +4 oxidation state with fluorine, chlorine as well as with bromine. That means VF5 exists, VF4 exists, VCl4 exists, VBr4 exists, but Vi4 that don't exist. This one exists. The students who are also considering about the IIT main, advance, the NEET examination as well as for the CUT examination, those guys watch out this one very seriously. Okay, be concentrated here. So BF5, this one exists. Now same here, about this one chromium when you consider. So chromium the chromium will form +4 oxidation state with all the halogens. But the +5 oxidation state and +6 oxidation state, it will show only with fluorine. That means chromium shows +5 and +6, and this one. Okay, now with the other halogens it show, that means from fluorine to iodine, it shows the oxidation state from +2, the oxidation state of okay. Then after manganese, here when you comes here, the maximum oxidation state of manganese is +7, but with halogens it shows only +4 oxidation state with halogens, and that's only with fluorine. So fluorine shows the maximum oxidation state of +4 with halogen, and that only with, among the halogen, only with fluorine, and +3 here also with fluorine. So from chlorine, bromine and iodine, all of them with other halogens, it shows the maximum oxidation state of +2 only. Keep in the mind, the manganese shows the oxidation state of +3 as well as +4 only with fluorine. With other halogens, it shows the oxidation state of +2 only. If you want to write, you may write. Okay, so these points are too much important for your NEET, more important for your IIT and NEET examination. In CUT examination, there is also high probability of asking this question. Same, iron +2 and +3 oxidation state source, and that source, that means here. But +3 oxidation state, same here. Iron shows the +3 oxidation state with fluorine, chlorine and bromine, but not with iodine. So same here, iron shows the +3 oxidation state. Clear here? Same here, cobalt shows +3 oxidation state only with fluorine, and with other halogens it shows the oxidation state of +2. Nickel shows the oxidation state of +2 only, and with any halogens it shows the +2 oxidation state. Now let's see about copper. In case of copper, the oxidation state shown by copper will be +2, obviously maximum +2 and +1 that shows. So +1, it will show +1 oxidation state, it will show with chlorine, bromine and iodine. The copper show +1 oxidation state, not with fluorine, with chlorine, bromine and iodine. Okay, so copper Okay. And copper shows the oxidation state of +2 only with fluorine and chlorine. Okay guys, so these points is not too much important for the 12th board examination, but probability of asking this the questions from this one is cannot be denied. But these points which I have taught you right now, that is quite important for your IIT, NEET as well as for your CUET examination. And in how the questions has been formed, about that we will make a separate video. So that was about the trends in stability of higher oxidation states of halides. Now we will discuss about the trends of stability in one point I have left. Listen guys, about that oxides we will discuss also. Let's see about this one oxidation here. If Cu2I2 there be, if suppose Cu2I2, no sorry, Cu2, what we have discussed here in the previous year. Let's see that about goes to the previous data. Here copper shows the oxidation state of +2 only with fluorine and chlorine and not with bromine and iodine. And if there be the iodide of, Cu2 plus, that means if there be Cui2, like this one. So it will dissociate into Cu2I2 and I2. So 2 moles of copper will require here. Because copper don't shows the oxidation state. Copper don't shows the oxidation state of +2 with bromine and iodine. But if Cui2 has been, if there is a compound that is Cui2, then that will get oxidized and form Cu2I2 and I2. In the same way here, the compound in which copper shows the +1 oxidation state. You are aware that among Cu plus and Cu2 plus, the Cu2 plus is more stable. Why? Because the hydration enthalpy of Cu2 plus is highly negative. Compared to Cu plus, the hydration enthalpy of Cu2 plus is highly negative. That's why Cu2 plus is more stable than Cu plus. So copper, when that will be in +1 oxidation state, when copper will be in +1 oxidation state, then that will undergo in disproportionation reaction. Firstly, let's see about the what is disproportionation reaction. Okay, so the reaction in which the same compound will oxidize as well as reduce. The reaction in which the oxidation and the reduction will take place of the same compound, then that reaction will be called disproportionation reaction. Redox reaction is what? The reaction in which the oxidation as well as the reduction takes place. That is called that is called redox reaction. Oxidation reaction, that means the reaction in which oxidation will take place. That means the reaction in which the oxidation number of an element will increase. That will be called oxidation reaction, and the reduction reaction will be the reaction in which there will be decrease in oxidation number. In a redox reaction, because oxidation, reduction cannot take place, and without reduction, the oxidation cannot take place. So, in any reaction, if there will be oxidation, then there must be the reduction. And in the reaction, if there be the reduction, then there must be the oxidation. So, the oxidation and reduction takes place simultaneously during a reaction. In disproportionation, the same compound will get oxidized and will get reduced. That means the oxidation and the reduction will take place of the same compound. So that is called disproportionation reaction. Here, copper, when will be in +1 oxidation state, then that will undergo in disproportionation reaction. That means Cu plus will disproportionate. So, when Cu plus will get reduced, there will be a formation of copper atom, and when Cu plus will get oxidized, there will be formation of Cu2 plus. So, same here, Cu plus there is, so same compound will get oxidized. So, Cu2 plus and get reduced. Suppose if there is CuCl, suppose CuCl, so that will undergo, that will itself will give CuCl2 and copper. Okay, that is here. That was about the oxidation state shown by the transition metals when they have combined with halogens. Now we will discuss about the oxidation number shown by the transition metals when they combine with oxygen. Now, study this table carefully. Scandium shows only one oxidation state, that is +3. So that will form Sc2O3. Now, the oxidation state shown by the titanium is this one, +2, +3 and +4. Vanadium 2 +5. Chromium to +6, manganese to +7, then after +3, then after +3, then after that +3 from more than +3 oxidation state. Don't show after the iron. Okay, what's the reason here? Why the transition metals shows higher oxidation state when it combine with that? Why the transition metals show higher oxidation state when that combined with oxygen compared to that of halogens. With fluorine also, fluorine is more electronegative than that of oxygen, even though the transition metals show greater oxidation number when that combined with oxygen instead of fluorine. Why? Reason here. What's the reason here? Fluorine is okay, most electronegative, and oxygen is second most electronegative. But oxygen do double bond formation. Oxygen has the ability to do double bond formation. That's why when oxygen will combine with the transition metals, it will attract the 2 electron towards itself. that it when oxygen will combine with transition metals and if there be covalent bond formation. Okay, about that we will also come after this point. So if oxygen will combine with transition metals, then it will do double bond formation with transition metals and they will attract the two electron of shared pair of electron of transition metals and hence they will show greater oxidation number. But fluorine do single bond formation, so the fluorine can attract only one electron of the transition metals towards itself. Okay. Now one point more here, if greater be the oxidation number, more be the covalent characteristic. About that I have taught you earlier also. More be the oxidation number, more be the covalent characteristic. Because to release the greater number of electron, high magnitude of energy will require. And since that high magnitude of energy will be not available, that's why the transition metals will do covalent bond formation when it will show higher oxidation state. Okay, so let's see here what the oxidation number shown, that is here. We have seen here seen here. Now let's see the some important points about which we have not discussed. That is like ferrates, FeO4 2 minus, here is called ferrates, FeO4 2 minus. Or this one ferrates. What's the oxidation number of iron? So iron here, suppose X, 4 oxygen and oxidation number of oxygen -2, that equal to -2. So X equal to +6. So by the way, ferrates form during a number of reactions by the chance. If there will be the formation of ferrates in which the oxidation number of iron is +6, then this ferrate will immediately undergo in the formation of Fe2O3, in which the oxidation number of iron will be +3. You may calculate that. The oxidation number of iron will be +3 because, and here the frequently shown oxidation number by the oxygen is Fe2O3 here. That means more than that, +3 oxidation state. Iron don't show. Usually iron don't show the oxidation number greater than +3. So here in any case when iron have form a compound in which it exhibit the oxidation number of +6, then immediately that will get reduced to Fe2O3. Okay, so keep this reaction in your mind. Okay. Okay, someone here also, like oxides there is oxocation also, in which the elements stabilize them, like vanadium in plus VO2 plus here. So here vanadium show the oxidation state of +5. So like oxides, some metals also form oxocation. Oxocation means the oxides of the transition metals and there will be a positive charge, like VO2 plus, VO2 plus, Ti4 plus, and like that, like this one, oxocation also form. Okay. Now greater with the bond, greater with the covalent characteristic here, greater with the covalent characteristic will increase like this one, like CrO3 here, predominantly chromium trioxide, that is predominantly covalent. Mn2O7, that is also covalent. And what's the shape of MnO27? That's frequently asked in the examination. The shape of Mn2O7. Listen here. How's that? Suppose this is a manganese here. This one is manganese. Here oxygen, oxygen, oxygen. And through this oxygen, the other manganese will be bonded. This one here, Mn, this compound is Mn2O7 we have to discuss. So here manganese it is, this oxygen, this oxygen, this oxygen, this 3 oxygen, through this oxygen, one more oxygen, through the oxygen, both the manganese will be bonded. Suppose there will be oxygen, it will get bonded here. So this geometry at this one, this geometry is tetrahedral. And this geometry is also tetrahedral. So the shape of Mn2O7 will be the true tetrahedra bonded at the oxygen atom. The shape of Mn2O7 will be the two tetrahedra bonded at the oxygen atom. Okay, so that's the shape. So we always keep in your mind about the shape of Mn2O7. So the shape of Mn2O7 will be two tetrahedra bonded at the oxygen atom. Okay, that was. Then after this here, let's see about how would you account for the increasing oxidizing power. About this one, I have already discussed here. You answer by yourself, and if anyone would like, if any students would like to check that by writing the answer of this question, I shall get the full marks or not, then he may comment in the question in the comment box of the YouTube channel Educate, and from there he may ask and may consult to the YouTube channel of Educate. Okay, definitely I shall check what you have written, and by writing that answer you will get full marks or not, because this question will be more important for the 12th board examination, not so much important for the NEET examination as well as for the IIT examination or the CUET examination. So who is preparing for 12th board examination, that may ask in the comment box, and if he will send his photograph what he have written, then I could check the answer of that questions also, and will inform that out of 2 marks how much marks you will get. Okay, now let's see here how you would account for the regularization of addition therapy. So these questions we have discussed this one very easily. So these 2 questions are very easy, about which we have discussed. Okay. Then after is chemical reactivity and standard electrode potential values. Okay, chemical reactivity and standard electrode potential values. So about the standard electrode potential, we are already aware that more negative be the standard electrode potential, then that element will have greater tendency. If more negative be the standard electrode potential, then that element will have the greater tendency to get oxidized, and less negative, then less tendency to get oxidized. About those reactivity, we have already studied in detail. There is no any point mentioned here in this topic about which I have not discussed. So if you will read this topic from here, the NCERT book, you will realize that there is no any additional information mentioned in this topic. Okay, now let's see, proceed on this one. This question, I have also already discussed about this question, but even though maybe from number of times I told you that this one is repetition, might be you feel hectic. So I just only hint you in the shortcut form. I tell you about this question. Listen here, for the first 4 transition metals, the standard electrode potential value has been given. Okay. Then after here, watch out, the question is here, explain the irregularities in the above value. So what's the irregularities here? Here standard electrode potential has been less negative, then after again became more negative. So why more negative here? Manganese. Firstly, the standard electrode potential of vanadium is highly negative because its sublimation enthalpy is very less. Write that here, the standard electrode potential of vanadium V is highly negative. It's V, not U. So don't be confused here. It's V. Sublimation enthalpy means sublimation is what? When any element undergo in the vapor phase directly from the solid phase. That means the element will undergo in the vapor phase without undergoing in liquid phase. Then that is called sublimation. Actually, so much heat energy has been supplied that the elements have undergo in the vapor phase instead without undergoing in liquid phase, or when there will be meager difference in the melting point and the boiling point of the element. If there be only meager difference, then the melting point and boiling point of any element, then that element will directly undergo in the vapor phase. Okay, so let's see. One is that. Then after manganese highly negative came here, and then after again starts decreasing. So no anomaly, that is here, and copper positive. Why positive? We have discussed already. Then after this decreasing. So we will have to explain about the less value of standard electrode potential of manganese. Let's see here. Highly negative vanadium, chromium not too much negative, and then after manganese again high negative. That means from the chromium there is tremendous fall in the standard electrode potential of manganese. So about the manganese, so you have you already know in +2 oxidation state the manganese acquire half-filled d orbitals, so which will provide them extra stability. So that's why the in +2 oxidation state its stability will be high. Okay, about that you already aware. Let's see next question. So why more positive? Here +3 oxidation state is less stable than +2 oxidation state, because in +2 oxidation state, the manganese contain half-filled d orbital. This one manganese contain half-filled d orbital. So +2, that means manganese will have higher tendency, Mn3 plus will have higher tendency to come in +2 oxidation state. So standard electrode potential will be much more positive. Now let's see about Cr3 plus and chromium here. You already know, goes on the electronic configuration. Here Cr3 plus is more stable than that of Cr2 plus. So chromium, that will be less negative. Now iron, here same. Why here chromium in +3 oxidation state? Its T2G energy level is half-filled. The T2G energy level of Cr3 plus is half-filled. That's why Cr3 plus is more stable than that of Cr2 plus. That's why there will be less, Cr3 plus will have less tendency to undergo in +2 oxidation state. That is Cr2 plus. Same here. In case of iron, Fe3 plus. In case of Fe3 plus, the Fe3 plus contain half-filled d orbital. Fe3 plus contain half-filled d orbital and Fe2 plus here. So Fe3 plus will have less tendency to undergo in Fe2 plus. That's why the standard electropotential of Mn3 plus is more negative than that of Cr3 plus or the Cr3 plus slash Cr2 plus, as well as for Fe3 plus slash Fe2 plus. Okay, this one is just like the repetition of the concepts about which now you are already aware. That means you cannot say that you are not acquainted by the concepts related to solve the questions of these D block elements. Okay, and I hope who have listened the lecture of mine, they could solve the questions of exercise also. But even though I shall discuss on those questions in the short form, that means fastly I shall discuss. Okay, now let's see. Same here, why is the highest oxidation state of metal exhibits in oxides or fluorides only? You already aware that why fluorine is more electronegative element, as in addition to that, the hydration enthalpy of F minus is highly negative. Okay, oxygen, in case of oxygen, that means most electronegative element. First one is fluorine is most electronegative, and second one is hydration enthalpy of F minus is highly negative. Second, first about the oxygen, what is here for the why the transition metals exhibit greater oxidation state in oxides. So one is here oxygen, second most electronegative element. Oxygen is second most electronegative element. In addition to that, oxygen do double bond formation with transition metals. So oxygen also shows greater oxidation state. That means when oxygen combined with transition metals, then the transition metals shows higher oxidation state. Next one is among Cr2 plus and Fe2 plus, which is more stronger reducing agent. So what happened here in Cr2 plus and Fe2 plus? Let's see here which one is more stable. So Fe2 plus, in case of Fe2 plus, that acquire the half filled, the Fe2 plus is will contain the Fe3 plus will contain half filled d orbital. So Fe2 plus have high tendency to undergo in +3 oxidation state. That's why, and in Cr2 plus, okay, T2G energy level will be stable, but T2G energy level will not provide so much stability as the half-filled d orbital of Fe provides. That's why Fe3 plus, it will go in +3 oxidation state, so it will act as a stronger reducing agent. That means Fe2 plus will act as a stronger reducing agent compared to that of Cr2 plus. Okay guys, we have discussed about this one. From the next in the next lecture, we will discuss about the magnetic properties of the transition metals. It's all for this class. Thank you, Team Educate.